Okay, welcome to part 13 of our series on quadratics. We're now going to have a look at solving quadratic inequalities. Okay, now this is just an introduction, okay, and we'll start with a simple inequality here. I've also drawn its graph here so you can see where the two solutions are to the equation. Okay, now we're going to start by considering this as an equation. All right, so we would look at that and try to solve it in the normal way because we're interested in finding out where it crosses the x-axis. Well, I look first to factorize it, and I can see that if I put 2x there and x in the second bracket, it will factorize. Okay, and the factors will have to be that we need to get 2, a positive number, and this is negative, so it must be both negatives, and it will be -2 and -1. Okay, and from those two brackets, if it was an equation, I would be saying, well, x must be a half to solve this first bracket, because 2 times a half is 1, take away 1 is 0, and x equals 2 to solve the second bracket, because 2 minus 2 is 0. Now we call these two numbers, okay, when we're dealing with inequalities, we call them the critical values. Okay, the critical values, and we should write that down when we do this. Okay, because we're not interested in the solutions to the equation, because it's not an equation but an inequality. Now, what those are the points where we either become interested or not in what the graph is doing. So at those 2 points, which are shown here, by the way, a half and 2, what I do next, if I'm solving this algebraically and there isn't a graph, I do a little sketch. And all I'm interested in is the 2 points where it crosses the x-axis. So I don't have to do a detailed drawing with numbers and everything. I just need to show these 2 points. Okay. Now, this thing here has to be less than 0. All right. So that happens between here and as it goes down here, all of that part of the function is negative. It's below 0. As soon as it comes back up to the x-axis and goes above it, it's then greater than 0. Now, this part is a single piece of the curve that satisfies this inequality. So I describe it with a single 3-part inequality like this. So my answer is that a half, okay, is less than x, which is less than 2. Okay, in other words, it's telling me that x lies between a half and 2, but not inclusive, because this inequality doesn't include, it's less than. So these are both less than. And that's my answer, a single 3-part inequality matching the single piece of shading on here. Okay, now just suppose instead the question had been not less than but greater than. So suppose it had said that 2x squared minus 5x plus 2 has to be greater than 0. Okay, well, it would have been a different outcome, because what I would have done is I wouldn't have shaded that in. I would have gone through the same process. I would have found the 2 values of x, the critical values. I would have gone to the sketch graph showing clearly a half and 2 on my graph. In fact, I'll write the half in there as well, because that's what you would need to show. Okay, that's at this point here. But what I'm going to do now is say, well, the function has to be above 0. And I notice that that can happen from here onwards. Okay, so from 2 upwards, it can, in fact, forever, it goes on up, forever getting more and more towards infinity. And also, if it's to the left of a half, okay, it's also positive until it gets to here. Now, I've shaded in and identified two distinct parts of the quadratic curve. And because of that, so I do all the same things here. When I get to this stage, I'm saying that x is got to be less than a half, okay? In other words, to the left of here, this way, or, okay, x is greater than 2. Okay, so what I've done now is I've given two distinct and separate inequalities to correspond to the two distinct and separate bits of graph that I'm interested in. Okay, so that's an introduction to quadratic inequalities. There will be more to follow in further videos where we look at more complicated situations and where a linear equation is also involved as well as a quadratic. Okay, that's it for now.